So the value of B in our last session, we saw that it was generating -5 as the result. Now in this session, we have to learn why -5 is the output. So we have to see it very carefully, and here we'll come to know more about Java, that how it handles the numbers and all. So first of all, see the value of 4. Sorry, B, that is 4. Fine. Now, how the 4 is represented? Look at this, the same Excel. B. This is how the number 4 is represented in RAM. Now, when we have done not of B, that is E, so it has generated this. Now, if this is the result, then how come this is -5? How -5? So this is what we have to understand. So in order to understand this, why this is generating -5 as the result, let us now try to understand few things. Java uses an encoding known as 2's complement, which means that negative numbers are represented by inverting, that is changing ones to zeros and zeros to ones. All of the bit in the value means in that value we have to change all the zeros to 1 and all the ones to 0, means we have to just invert them and then add 1 to the result. For example, -42 is represented by inverting the bits in 42. This is 42. How? See this. 42, look at this. 42, take to bin function is used through which it is converted to this. Now what? If you'll invert all the bits in this 42, look, 42 is made only from here to here. There is one, this only makes 42. But in a RAM, it is of 8 bits, 1 byte is 8 bits. So these 2 zeros are placed. So this is how it become a byte, 8-bit sequence. And when we convert this 42, or when we invert it, it yields this. How it yields? See, 0, 0, which became 1, 1, 1 became 0, 0 became 1, and like this, these all are converted. And then adding 1, which result in this. And this is -42 for Java. And this method is called 2's complement. Now, to decode the negative number, now how can we come to, suppose this is the number which is stored in RAM, then how can we come to know that this is -42? First invert all of the bits, then add 1. For example, -42 is represented by using 2's complement method like this, which is same to this. Now we are decoding it. I mean, we are compiling it back to how we can understand that how this number is -42, how it is being done. So first of all, this is inverted to this. And so all the ones has become 0 and all the zeros has become 1, which is 41. And so, and again, one more is added to it. Then it yields 42. So this is how this number is converted back to the original number, whatever number is 42. So this is how 40 exactly. Actually, the number positive 42 is represented this way. Where is it? See this. This is positive 42, but negative 42 this. In order to decode it, we use these things and we finally come up with this. So here also in this case, when we got minus 5 as the result because of this operation, or you may say this operation. Now here we have to try to understand why minus 5. So for now, when we converted it back to, when we use the not operator, not bitwise operator, and it has been told to you earlier that the not bitwise operator simply changes 1 to 0, 1 get changed to 0, and 0 get converted to 1. This is what happens. So when used with not operator, this it yielded. How? See, 0 became 1, 0 became 1, 1 became 0, 0 became 1, and this is how these things are happening. Now what? Let us use the 2's complement method. So see here, the 1 is converted to 0 back. This 1 is converted to 0. This 0 is converted to 1, and all the ones and this all is converted to 0. Now what? You have to add 1 to it. So when we add 1 to this, we are using the 2's complement method to decode which number is this. We are decoding this number. Just now we saw that how minus 42. So we first converted it to inverted the numbers and added 1 to it. So here also we are doing what? We have inverted and we are adding 1. And when we are adding 1, look at this. Now this cell number 13 or cell number 12 here what we are doing, we are adding 0 plus 1, 1. This is 0. This is 1. Rest all 0, 0, 0, 0, and 0. So this is the new number which is generated. Now what is this number? Let us find it through the conversion 101. This number is actually 101. Now this 101 makes what? 5. And this number, when it decoded back, it yielded 5. And so this number is minus 5. And that's why we are getting this result as minus 5. For most of you, this may be a little complicated how these things are working. But once you will study in your own, if you'll try to understand, or if you'll see a few more examples, then the things may become a little more clear for you. So students, now it is up to you that how well you are self-studying and doing practices. It has simply decoded this number. In the beginning, if 1 is there, it senses it has the negative number. And when it senses that it has to be represented in a negative form, then it uses the 2's complement method. And in 2's complement method, what happens? The thing is first inverted. Inverting means changing 1 to 0. So all the 1's became 0's and all the 0's became 1. This is, and adding 1 to it. And when we are adding this, we are getting this. And this is the actual number, which yields 5. And thus this number has been decoded back to minus 5. And that's what we are watching here. Fine. So now we have few more operators with us, bitwise operators. This is the another one, which is left shift. The left shift operator, which is indicated by this, shifts all of the bits in the value to the left a specified number of times, like this. And we could better understand it with the help of example. Yes. Now here we can see a nice example. Byte A equals 64 and another byte variable B. Now we can see here earlier, other than this left shift operator, these operators were asking for integer data type. Yes, there must be integer with that we saw in the last video. We had to change it to the int. But in left shift operator, you see that the byte data type can be used. So let us now make change in that program to see the left shift operator. So let us make a new byte variable n1. Let us make it 64. So let us see how this byte variable, what is the variable name? Variable name is n1. What is its value? Its value is 64. 64 means this one, and how many zeros? 1, 2, 3, 4, 5, 6 zeros. Yani ki 1, after that this, and one more zero at this time. So this is the number 64, which is the value of n1. Its binary value is this, and this is how the byte, it's taking 1 byte because this time it is byte variable. Now we have to see the use of left shift bitwise operator. We'll see the same way. Very nice example. Look at this. One more int is there. Int means how many bytes? Int means 4 bytes. So we'll do the same thing in our program also. Nice program. Int I, and let us make another variable n2 also. The same way, the way in which it is made in this program, the same way we are using the same thing. Now what? I equals n1 2. Now what does this 2 means? I'll make every point very clear. Left shift 2. Okay, let me first run this and then I'll show you. B equals explicit type conversion. A here is n1 2. Now I is integer and B is byte. Now actually we had to use here n2 because we are not using P. Don't get confused, dear students. It's quite simple. For I and n2. I space n2. Now let us compile this and first see the result and then errors. It's okay. Expected. Simple mistakes are there. No, did worry much. INTI. और कुछ Mhm. Again, very simple mistake. This should not be there. Hmm. Look, the value of N1 is 64, but value of I is 256 and value of N2 is 0. Now let us try to get why so. Look, left shift 2 means what? It has to shift 2 bits to left side. I mean, this side, this side. If you will, I mean, see, uh, left shift means this side. If we'll shift 2 bits to this side, then what will this will become? Look, these 2 bit will go off. 2 bits to left side. That will go off and this whole thing will become 0 because these 2 bits shifted to the left. And therefore, the byte, since it contains only 8 bits, so now all the bits has become 0 and therefore the value of N2 is displaying 0. Now why the value of I is displaying 256? So let us make this variable as I. I means how many bytes? 1, 2, 3, 4 bytes. This is I. Let me make this more clear. Now if the left shift 2 bit happens, then this all has become 0. Yes.